Hello geometry students, today we are going to learn about segment relationship in circles. That's section 10.6. It's on page number 305 to 306 from Big Idea Geometry Student Journal. So in this section we are going to learn about three theorems and few concepts. The first theorem is 10.18 segments and chords theorem. Then 10.19 segments of secants theorem. Then 10.20 segments of secants and tangents theorem. Alright, so let's start the section. So we have first vocab here, segments of chord, that we have to understand what is segment of chord. If we draw two chords here, our chords are AC and BD, and when they intersect inside the circle, so in that case the segments are going to be, so in this case this is the chord here, this is a part of the chord, this is the part of the chord, so these are the segments of the chord. Same way we have another chord, that is DB, and the parts of the chords are this one and this one. These are the segments of the chords. So you have to basically look at the chord and its part. So let's move to the next part. Next concept is about tangent segment and secant segment. So we done the chord segment, now we're going to talk about tangent segment. So tangent segment is just like the parts of the tangent. If you have a circle given here and you see the first one, PR, is actually a secant, so PR is the secant here. So you have to identify the things and then the parts of that. PR is the secant and PS is the tangent. So difference between secant and the chord just starts on a circle, ends on a circle. In this case QR is a chord, but when it goes out like PR, the whole thing that becomes a PR is a secant. Alright, so let's define what's a tangent segment. Tangent segment is basically you have the part of the tangent here, this is the tangent segment. Alright, and what is the external is a segment that is tangent to a circle at the end point. So from end point to the whole tangent. Alright, so after that we have another thing is called secant segment. Secant segment is the whole secant here, starting from here to here. That's going to be a secant segment. That's a secant segment here, and it is this one. And secant segment is PR. PR is the secant segment, but if we are talking about the external segment, so from the secant, whatever the part is outside the circle, that's going to be called the external segment. So in this case this is called external segment. This part is called external segment, that is PQ. PQ is the external segment, that's outside the circle, and that's the part of the secant. Alright, so that's a secant. So here it says that the secant segment is a segment that contains a chord of a circle and has exactly one end point outside the circle. So it has a chord, but when it goes out then it becomes a secant. And also external, it's the part of the secant segment that is outside the circle and is called an external segment. Alright, let's move to the theorems here. Very first theorem here, secant of chords theorem, means if we have chords and there are secants, what theorem we can talk about. So we can see there are two chords. Chords are if we talk about chords are here, in this case it's going to be AB and CD, they're the chords. So this whole thing, this and this, they're the chords. And what kind of theorem we can make from it? We can say the parts of the segments of the chord. So I have to look at the chords, the parts. So this is first part, this is the second part of AB. So you have to just write down the expression for that, the name for these two segments. So the first part is EA or AE, whatever way you want to write it down. If I want to write it down, I can write down AE, that's also correct, not wrong. And the second part is BE, I can write down BE. Expression they're using EB is the same thing, because we know the segment that's so here that's the same thing, we can write the expression same way, and that's equal to, here they're using what, they're using EC times ED. So they're using EC, this part, and times this part. All right, EC time ED. So we have EC time ED, and if we are writing the name other way, we can write down CE time DE, and actually that is E, for your information. All right, so that way it's only the name, difference of the name, how you write it. So it's actually for segment 1 in sorry, it's about chord 1. So chord 1 and chord 2, and just how to write the expression is just like the part times part for chord 1 equal to part times part. This way you write it. So this is coming from chord 1, this thing, and this thing is coming from chord 2. Just multiply the parts, that way you can easily write the expression. Now if you already got it, so what you need to do, you need to basically, you have a picture given here on left hand side. Stop the video and try to write the expression for segments of Chord's theorem, and you can always check it. So in this case, our expression is going to be this and this part. So our first part is going to be here, I will write SR times QR equal to, another two parts are this times this part, and that is what, PR times RT. That's PR times TR. Up to you how you want to write it. So that's our expression for segments of Chord's theorem. Let's move to the next theorem. Next theorem is segments to the of secant theorem. So segment of secant theorem. So it means now you're going to look at the segments of the secants. Here first let's identify the secants are, which one are the secant. You see the secants are basically, this is the secant and this is the secant. You have two secants. So in this case EB and ED. So your two are EB and ED. That is EB and ED, they're the two secants, and we have to look at the parts. So it says that two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of lengths of other secant segment and its external segment. So just let's make it very simple. What does it mean? You have to just look at the external, the part which is outside here. So if I just see, this is the part which is outside, and then you have to look at the whole part. The whole one is let me use different color here. Whole one, or let me use this thing. Whole one is this thing. That's the whole one. So how to write it? You have to basically, that's EA, the external one, times the whole one. The whole one is EB. Okay, so basically what it is, this is the external times whole chord. All right, so EA times EB, same thing for the other chord. That's that's the external here. So sorry for the line is not drawn correctly. So that's EC. So that's EC here. We have EC, that's external. So we can write down that's going to be again external times ED is the whole now. So we can going to take the whole chord, that's ED. ED is here, and that's what? Whole. So how to remember this formula? External times whole, external times whole equal to external times whole. And the first one, the first part that's coming from, this is coming from first secant, secant 1. You can assume any secant to be the first secant and second secant and secant 2. So you have to just multiply it in this way. So now you have another question, another picture here, and you are supposed to write the expression for segments of secants theorem here. The secants are RP and TP. You write it. If you know you already understood it, stop it and write on your own, and then match your answer with me. So, all right, so let's see what it is. So here our the whole secant is what? Our whole secant is actually, this is R to P or PR. And what is the whole secant in the other one? It is this one. That's what TP. Now it's up to the end, the whole thing. And what is the external part here? It's the external part in this case. This is the external part, and this is the external part. We have to take that the whole time external. If we have to write down the expression, what we will write PR is the whole time external, PR is the whole here, and QP is the outside one, is this one, QP. Oh, I just wrote QR. QP, PR and PQ, up to you, you can write anyway. And then after that, for the second secant, it's going to be PT times then external one. The external one is this one. This is the external. What is that? That's SP or PS, up to you, whatever way you want to name it. And that's going to be PS. So let me write down the name in the same order here. That's looks, instead of QP, let's write PQ. So same way. All right, doesn't matter how you choose your name, it's the same thing. So that's the expression for segments of secants theorem. Let's move to the next theorem, and the last one, segments of secants and tangent theorem. So you're going to have two things here. You have segments of secants and tangent theorem. You have to have a secant. Secant is what? In that case, your secant is ED. That's the secant. ED is the secant here. And then tangent. Tangent is basically here, in your case, the tangent is EA. So tangent is EA. And we're going to write the theorem for this. So let me just erase it. All right. So what does it say? It says that if a secant segment and a tangent segment share an endpoint outside the circle, or simply they meet outside the circle, then the product of the lengths of secant segment and an external segment equals the square of the length of tangent segment. So it is very same as the last one. So part to the whole, like the last we did here, where we were talking about, it was part to the whole or external times whole. It's almost the same way. So here, if I have to apply the same funda, how can I do that? So here we have, that's the external, but where is the whole part? Itself, it's the whole. So here it's the external part, and where is the whole? We see The first case, this is itself a whole and the part, and here this is the whole. If I have to use that logic, if I have to write it external times whole, so external times wholes means the first one EA, that's the external, and EA is itself the whole, equal to EC for the other secant here, EC, that's the external, and whole is ED, EC times ED. And then EA times EA is just like you have x times x, that is what, x square. So EA times EA is EA square, it is what, EC times ED, and that you have got here. You can see that EA square is what, EC times ED. So it is exactly same way written. Now you have a figure on your left hand side, and you can look at it, you can stop the video again, and you can try to write the expression for segments of secants and tangents theorem. So let me give you the answer here. So external part here, this is the external part here, and this is the external part here for both things, and we have to identify the bigger part. Bigger part is this one, and here it is the bigger one, the whole one. That's it. So let's write it down. So if I write it down, for the top one, the PR, the secant PR, if I have to write, or let's start with the tangent, because they started with the tangent. For tangent, the external is what, SR, and whole is what, itself SR. And what is the external for PR? PR is QR times, and the whole is PR. All right, so QR times PR. All right, so the whole, and then it becomes SR square is equal to QR times PR. QR is this one, the outside one, and PR is the whole one. All right, I hope you get it. Any doubt, please leave a comment. I hope you get it. Thank you so much for watching. Please like, share and subscribe. Stay safe. Bye.